Hey guys, I hope you had a good weekend, and I hope that the first two lessons went well for you guys. I hope that you were able to see everything clearly, understand everything clearly. Hopefully I wasn't going too fast. Good thing is, if it is a little bit fast, you can pause because it is a YouTube video, or you can go back and rewatch it, but I'll try to keep the pace kind of steady since so far I haven't heard any complaints about it. Um, if there's anything you guys want me to change, let me know. But we're going to go over what we did at the end of last class, which was Thursday. And hopefully you guys didn't have any issues with it. Again, if you guys want me to make any extra videos to clarify some of the things we talk about, let me know, and I'll definitely try and find the time to do that. I've got not a ton of work to do for this weekend, so maybe I'll try and make something over the course of this week. So, we were talking about differential equations last week, and we got up to differential equations of the form y prime plus q of x times y equals some function g of x. Now, it's important to note that while I haven't written it in, this y prime and this y are also functions of x. So it's really y prime of x plus q of x times y of x equals g of x. All right? And remember, little q of x is defined as big Q of x divided by big P of x, and little g of x is defined as big G of x over P of x. And the reason we have this P of x here is because our original version of this formula was P of x times y prime plus q of x, big Q and big P of x times y equals big G of x. And so that's why we had the p in there, and what we did is we divided out each term by p, and so when you divide this first term out by p, then the p of x term disappears and you're left with just this y prime. When you divide big Q by big P, we call that little q, and we put that right here. And when you divide big G by big P, we call that little g, and we put that right here. And so now we have y prime plus q times y equals g. That's little q and little g. So that's a little bit of a refresher from what we covered last week. And then we talked about, once you've got it in this form, how on earth are you supposed to solve it? Because at the start it looked like all you had to do was already know the answer, or just make a wild guess and hope that it was right, and if it was wrong, make a different guess. And trial and error is not always the best option. So we talked about how to solve for y. How to solve for y. And the first thing you have to do is calculate what mu of x is, which we defined as e to the integral of q of x dx. I hope you guys can see that. Looks good on my screen. So you have to calculate mu of x, which is equal to e to the integral of q of x dx. And a couple of important things to note here. Actually, before I go on, I wanted to mention in my notes, when I was looking over them, all of these x's in the brackets were t's in my notes. It was always the letter t, and so I may accidentally somewhere have written a t last time and I didn't catch it, or I might do it this class or in a subsequent class, because I've dug out my notes from when I took a course that covered this stuff, and so I do apologize if a random t shows up here or makes that a dt or something like that. It's all supposed to be x for our purposes. Second thing is this right here, mu, is called, in this case, it's called the integrating factor. Is that what it's called? Is that what I said? Let me just quickly double check that. I have it somewhere. Yeah, alright, that's what it's called. That's what it looks like. Yeah, so we calculate the integrating factor first. Alright, and that's mu. And then what happens is we move on and we calculate y, which is 1 over mu of x times the integral of mu of x times g of x dx plus c. Now, a couple things. That's an awful bracket. Couple things. This plus c, normally when you're doing an integral, you don't need to put this plus c before you solve the integral, and we never did put it in when we were working with just regular integrals without this bigger picture to it. This is just here to kind of help you through solving an integral when there's other stuff being multiplied into it. It can make a difference, and it can stop you from being confused when you see this plus c already taken care of. Similarly, the plus c out here in this integral doesn't matter. If you guys want me to make a footnote explaining why, I can do that, but let it suffice to say that the plus c from this integral up here, when you calculate mu, doesn't actually matter. So, this is the solution to a dE of this form. When you've got y prime plus little q times y equals g, little g, then this is how you solve for it. So you calculate mu, which is this thing over here, and then you calculate y based on that, because you'll already know what g is. You'll have just figured out what mu is here and here, solve the integral, multiply it together, and you're good to go. And so what I'm thinking we'll do is, just real quick, we'll go over the example from last class because I was panicking about the length of the video. Good thing is YouTube did not really fuss when the video turned out to be just a little bit over 15 minutes. So maybe I won't be quite so pressed for time, but we'll see how it goes. I'll try to keep it under 15 minutes just in case it becomes a headache if it's significantly longer than 15. But our dE from last time was y equals y prime. And so when you're calculating mu, first things first, we got to get this into the form of y prime plus q of x times y equals little g of x. And so in order to solve for mu, we need to actually figure out what this q is and what this g is before that, because it's not necessarily going to just be like 1 and 1 or something like that. Alright, so if we want to get this into this form, we're going to have to bring this y prime over to the left side of the equal sign, right? And if we do that, we get negative y prime, because it was positive on that side. So if you subtract out a y prime from each side, this side you get 0, and this side you get negative y prime. So you have negative y prime plus y equals, and because we subtracted out y prime from this side, we got nothing left over on the other side, right? But based on this original formula that we wanted in, we want y prime to be positive. And so what we do is we multiply every term by negative 1. And if you multiply this by negative 1, the negative sign disappears. If you multiply the y by negative 1, you get a minus sign there. and then 0, it doesn't matter if it's positive or negative, so no problems there. So now we have this in the form that we needed up here, and you can identify now that y prime is in the right spot, y is in the right spot. This is where g of x is supposed to be, so what we know is that g of x is equal to 0, just by comparing these two lines. G of x there, 0 there, g of x is equal to 0, and here we have positive q of x times y, and here we have negative y. So if the y here and here is the same, what's changed is this q of x right here, this plus q of x that we're seeing right here, has to be contained within just this negative sign right down here. And so what that tells us is that little q of x is negative. Negative what? Can't be 0 because otherwise this term would have disappeared. But what it's telling us is that because we have no other number written there, it must be 1. Alright, so little q of x is negative 1. And g of x, little g of x, is 0. Alright, now based on that, what we can do is we can solve for mu. I know this is pretty much exactly the same thing as last class, but this is kind of advanced stuff, and so I understand if it's a little bit difficult to absorb the first time, so I wanted to go over it once again without rushing. And so we have to solve for mu, q of x dx, and so little q of x we said is negative 1, right? I'm going to get rid of everything except the q and g at the bottom. So we said little q of x is negative 1, right? So this e to the integral of q of x dx becomes e to the integral of negative 1 dx. Alright? Now, if you want, you could solve that it's a number dx in the integral sign, and so if you have just a constant, the integral of a constant is that constant times x, or what you can alternatively do is, because numbers tend to not matter as much in derivatives and integrals, is you can actually pull the negative 1 out. I'm just going to put the negative sign there because it's the same as putting a negative 1. And then all that's left on the inside is dx, and if you have nothing in there, you're essentially just integrating dx, which I hope you guys remember us talking about it. If not, it's a little bit of a refresher. This bit right here, the integral of dx, evaluates to just x. Alright, and then that negative sign from up here carries right over here. And so we now know that this is mu of x. It's e to the negative x. Alright? Now we also know g of x is equal to 0. I'm going to put that over here. G of x is equal to 0, and q of x is equal to negative 1. Alright, I got 2 minutes to finish this, and then we will move on to the next video. Alright, so now we got to solve for y, which is 1 over mu of x times the integral of mu of x g of x dx plus c. Alright? Mu of x, we know, is e to the negative x. So I'm going to plug that in both spots. Alright? E to the negative x. Same thing over here. E to the negative x. However, g of x right here is 0, meaning that this whole thing just disappears, because it's just the integral of nothing, the integral of 0 dx, right? The integral of 0 dx, which if you pull out the 0 and you integrate, it doesn't matter. You're going to be doing 0 times something, so this whole thing actually disappears, and all you're left with is that plus c all the way at the end. So I'm going to put that c right here and get rid of the rest of this. Alright? So that's all you're left with. you can multiply that c up into this numerator because it's technically c over 1 as a fraction, and then with multiplication you do numerator times numerator, denominator times denominator, you get c over e to the negative x. And hopefully you guys remember your exponent laws. If you have a negative exponent in the denominator, you can turn that into something that has a positive exponent in the numerator. So that gives you c e to the x, which is exactly what we got last time. I'll see you guys in just a sec.